Well, it has been a dramatic journey, this topic, hasn't it? And this is the last lecture, summary with Q&A. So this lecture has two parts. In the first part, we revisit and reflect on the lectures. We look at a list of lectures, and so that you just see how much you've learned in this topic. And in the second part, I try to answer selected questions that I have received by students. So let's see how that goes. Yeah. First part, summary. Indeed, we're talking about an uncertain future. And it's really what happens in the next few years. Actions undertaken to combat global warming in the next few years will determine the climate for the next thousands of years. So it's not actions undertaken in 20, 30 or 40 or 50 years. It has to start now. Okay, in particular, no more new gas, coal, oil developments. Okay? And phase out fossil fuel rapidly. And that's what many people, many scientists call for. But on the other hand, you hear about new exploration plans, like in Alaska. Okay, that's an image above me. Okay, there's also plans for new oil projects in the Arctic Ocean. Okay. So that's really where we're at a crossroad at this point in time. Okay. So let's have a look at the lectures. Okay, so the lectures can be divided into parts. And the first part is really an introduction. Okay, and we looked at what is climate, looking at different vegetation zones that we have, looking at some basics, the structure of the Earth, and you learned what thermal radiation is and what cycles and fluxes are. And then we looked at how can we actually measure climate, and we looked at climographs, water balance diagrams. And that's all extremely useful stuff in order to understand the climate of a region. In lecture 4, I introduce you to regional climatic classification schemes. We can look at different latitudes, start with very simple climatic zones. Okay, and then I introduce you to advanced classifications, like the Köppen-Geiger classification schemes. And we also talked about climate zones of the ocean. Okay. And then before actually worrying about all the details, how stuff works, all the interactions, we just looked at past climate changes. Okay, so the focus was placed on temperature changes. Okay, because you understand what temperature is, and you don't need to understand much more. Here you needed to learn what climate proxies are and how you can date different types of samples. Okay, and then we looked at past climate variations. Yeah. Okay, on paleoclimate timescales. We looked at mass extinction events. We looked at hothouse and icehouse cycles and stuff like that. Okay. We learned about solar radiation, how that works, the solar constant and the global average or so, because that's sort of required in order to understand climatic zones on Earth in terms of the temperature. But we can also use this to actually understand ice ages or factors contributing to ice ages, including Milankovitch cycles that are linked to changes of the orbital path or orbital cycles. All right, and here you also were introduced to CO2. Okay, CO2 in terms of the reconstruction of climate, and you could learn that temperature and CO2 changes are often in tandem. Okay, in part 3, we started looking at the details. Okay, understanding the climate system. Okay, and we looked at the albedo effect and the greenhouse effect. Okay, we looked at simple radiation models and the Planck adjustment. Okay, and these considerations are extremely important to understand the climate system. Okay. Then we looked at climate feedback mechanisms, equilibrium states, runaway effects, key climate feedback mechanisms, aerosols, stuff like that, Okay. I introduced you to surface heat fluxes. What determines the surface heat flux? Because that's an important part, because if you're interested in microclimate, the latent heat flux is just such an important part in the surface heat balance of Earth, but also on smaller scales. And then we looked at how a substance reacts to a heat flux. If you have soil or if you have the surface mixed layer of the ocean, how quickly does it heat up or cool down? Okay, I introduced you to heat capacity and thermal inertia effects. Okay, and the second part of this understanding the climate system, you learn more about the atmosphere, the average circulation, vertical circulation cells, surface wind systems, and other features like tropical cyclones or rain shadows. Okay. We focus on the hydrological cycle, and that's the first time we actually focus on precipitation minus evaporation and distributions over land. And we looked at how the atmosphere actually creates deserts. The atmospheric circulation, how this is linked to the water cycle. Lecture 14, we discussed more features of the ocean, like surface temperature, distribution, surface currents, the thermohaline circulation, and ocean carbon pumps with a link to ocean acidification. Okay, so all these basics are really required in order to understand special features of the climate system. Okay, which we looked at in part 5. Okay, one is extreme events, and the other one is interannual climate variability. Okay, extreme events, we looked at different examples, and I introduced you to key statistical methods that are used. Okay, and you learned then in lecture 16 about the El Nino Southern Oscillation, North Atlantic Oscillation, Indian Ocean Dipole. Okay, and that's very, very important to understand this interannual climate variability, these modes of this variability. Okay, because it just determines the climate in so many countries, these variations. And then indeed there's a link to global climate change, and the key question is, well, how, for example, do El Nino, La Nina events, how does that change in the future? How will it change? Okay. And then we can really look at the influence of humans in the Anthropocene. Okay. In this part 6, we looked at climate monitoring and climate models, and then we looked at all the observed changes featuring the last 20 to 30 years, but going back something like 150 years. And then we look at all the observed changes from the atmosphere, hydrological cycle to ecosystems and the ocean and the cryosphere. Okay, and then with that we can actually look at other aspects like the scientific consensus, the consensus among scientists, climate scientists. We're talking about the IPCC key findings of the latest IPCC report. We look at climate projections for the future, emission scenarios, and various climate projections in terms of temperature changes, projections of changes in the water cycle. Okay. So in lecture 22, we talked about CO2 equivalent emissions, all about these emissions, international initiatives like the Paris Agreement, and we looked at actually greenhouse gas emissions per sector and per country, and global coal, oil, and gas producers, who produces how much. Okay. Lecture 23 was more personal, looking at environmental footprints, the carbon footprint, the water footprint, and the ecological footprint, looking at average footprints and distributions of footprints. Okay? And the last lecture is this lecture, the summary and Q&A. All right, when you look at these lectures and reflect on these lectures, I hope that you see how much you learned, okay, from the first lecture to the last lecture, and I hope that you can see that this knowledge will actually influence your mindset. When you hear some news, you use this knowledge actually to interpret the news on global climate change. So I hope this all works out like that. So this is the end of the first part.